Hey everyone, we're about to embark on a really important lesson. It covers something called the order of operations, and the order of operations is essential for moving forward in algebra. We have to be really good at this order of operations things. It allows us to evaluate and simplify algebraic expressions. And we'll be looking at some that are kind of complex because they'll have groups and exponents and add and subtract, multiply and divide all mixed in. And if you do something out of order, it will totally ruin your outcome. Let me give you a quick example. 11 minus 4 plus 6. I want you to pause the program and do that problem. Pause now and figure out that answer. Okay, hope you did. Some of you might have done this. Oh, that's easy. 4 plus 6 is 10. 11 minus 10 equals 1. Easy, right? But wait, somebody else might have said, wait a minute, 11 minus 4 is 7 plus 6, which equals 13. Now, how can we have one problem with two answers when we cannot have that? There's only one answer to this problem. Turns out 13 is the correct one. And if you got 1 on this answer, that's incorrect. And it has something to do with going out of order. So if you got 1, that's all the more reason for you to really pay attention when we do the order of operations, because that one got messed up. Another thing we're going to do is we're going to evaluate and simplify, and I want you to be able to understand the difference between those two expressions. This one's new. We've already done some evaluation. For example, a simple one, x plus 3 when x equals 7. Okay, if we know what x is, that's easy. We plug it in. 7 plus 3 is 10. That's evaluate. We've evaluated it. But here's a different one. Writing it up here on the top, 2x plus 9. Now, I'm not telling you what x is. I don't know what x is. So all we have is an algebraic expression. Can we find the value of it? Well, no. If I'm not telling you x, or if I don't know what x is, we can't find the value. But we can simplify it. It's a little complicated the way it is right now. And in the previous class, we learned the distributive law. So we could do a little bit of algebra to make it a little simpler. We could use the distributive law to multiply both terms. We get 2x plus 18. And now we have simplified it. We've made it a little simpler than it was. And when you have an algebraic expression, you don't know what x is. You can't get the value, but you can make the hard statement easier. Okay, so that's the game plan for today. We're going to focus on these things right here. All right, so here is that order of operations things that I was talking about. Now, order. First thing in the order is groups. Groups are high priority. There's parentheses, brackets, braces, absolute value bars, and there's fraction bars. How does a fraction bar make a group? It's because when you have a bar, there's a top, that's a group, and a bottom, that's a group. So it's like it doesn't have the parentheses on it, but in effect, the top has parentheses around it, and the bottom has parentheses around it. So the top is a group. You got to finish the top independently of the bottom. Once all your groups are done, then you move on to exponents. Then you do multiply and divide and add and subtract. Now, some of you may know about PEMDAS. People use PEMDAS for parentheses, E for exponents, multiply, divide, add, and subtract. And if you understand it well, you can keep thinking in terms of PEMDAS, but it has some problems with it. First problem is there's PEM starts with P for parentheses. There's more to grouping than just parentheses. There's all of these groups. So the P is kind of a misnomer. Second problem with PEMDAS is some people may look at it and think there's 6 steps to the order, and there is not 6 steps. There's only 4 steps. This is the first step, second step, and multiply to divide together are the third step, and add and subtract together are the fourth step. Now here's the third thing that can go wrong with PEMDAS, and it is the mistake we made before when we did 11 minus 4 plus 6. Some people will look at adding and say adding is more important than subtracting, and that is wrong. Subtraction goes first, always, if subtraction is on the left. Adding goes first, if adding is on the left. But in the problem I gave you, subtraction was on the left. That's why we had to do 11 minus 4 first. We did the subtraction first and then finished with the adding. Same with multiplying. If we did 20 divided by 4 times 5. They're looking at this and say, oh, multiplying is more important. It's not. Dividing goes first if dividing is on the left. So dividing is more important than multiplying when dividing is on the left. So this problem will equal 20 divided by 4, which is 5, then times 5, which equals 25. That's the right answer. Some people will say, oh, multiplies first. 4 times 5 is 20, and so they get 20 divided by 20, which equals 1. And that would be wrong, because I multiplied first. Multiply is not first. If divide is on the left, divide is first. So that's why we have to always think in terms of these problems as left to right. So that's the big picture on the rules. You can keep checking back on this. So as long as you keep PEMDAS straight, you can use PEMDAS. But I like my system here because it preps your brain for in the future when you're doing more complicated things. PEMDAS is just a little bit weak, but it'll work. So now we're going to practice. Okay, what's x? Well, there's no x's. It's just numbers. So we can actually get the value, but we have to follow the order of operations to get the value. So what goes first? Well, we look for groups. There's no groups. We look for exponents. No exponents. We look for multiplies and divides. There's a multiply. Okay, so I have to do the multiply. And then we look for adds and subtracts. But the multiply is before add and subtract. So we're going to go left to right, catch all the multiplies. So the subtraction has to wait. There's 5 times 2 is 10. And the adding has to wait. Done. Now we're going to go left to right and do adds and subtracts. So what goes first? I wish we were in class so I could ask every one of you. But subtraction is first because subtraction is on the left. So I'm going to go left to right. 30 minus 10 is 20. And then the last thing is plus a 9. And we get 29. There we go. That is evaluated. Now, we could also say we simplified it. So the words simplify and evaluate kind of get used interchangeably, especially when there's numbers. So we simplified all those numbers down to 29. Let's look at another one. Okay, so I'll keep progressively adding in some more and more difficulty here. Now, I'm seeing right off the bat, my bad, I have a typo. So let's fix the typo. It should say A equals 2. So we have negative 15 divided by 3 times the group 7 minus A, and the group is squared. What goes first? Groups go first. Okay, well, what is 7 minus a? Well, if we didn't know what a was, it would be stuck. But in this problem, we actually do know what a is. So I think it's safe to rewrite the problem and take a out and plug in its value. So we're going to have negative 15 divided by 3 times 7 minus squared. And we're going to take a out and replace it with its value 2. Okay, so now we can actually start doing the group. The group is the numbers and the math in the parentheses. So I'm going to take care of the group and do the math. 7 minus 2 is 5. We're done. Well, we're done with the first thing. After groups, what goes next? We look for exponents. Okay? And it turns out there is an exponent. Look left to right and do all the exponents, and there is one. 5 to the second power. So we'll have negative 15 divided by 3. Now notice the dividing is weighting, and the multiply is weighting. I'm not going 3 times 5 and getting 15. The multiply has to wait till the exponent is done. Now when I do the exponent, I get 25. 5 times 5. Now, because the group was 7 minus 2, that gave me 5, and then the group was second power, I got 25. I don't need the parentheses anymore. You can keep the parentheses there, or you can put a times dot, but we do have a multiply here. So you can drop the parentheses and just put a multiply dot, or you can keep the parentheses because that also means multiply. All right, done with the second operation, exponents, all done. Now we're looking for multiplies and divides and adds and subtract. So we're going to go left to right and look, are there any multiplies and divides? They sure are. Which one goes first? Well, I hope you're thinking division. Division is on the left, so division goes first. So I have to divide these two numbers. Now this is bad form. I haven't been putting my equals. Each step I should have put equals. Now I'm going to take that fourth line, get what it equals by dividing first. And so we're going to have negative 15 divided by 3, which is negative 5 times 25. Now we can finish off the multiply, and we're going to get negative 75. Done. All right, let's try another example. Okay, so this one doesn't have any x's or a's in it. It is all basically it's arithmetic, but it's more complicated. There's lots of work in here to do, but if we follow the order, no matter how complicated it is, we can get the correct answer. So in the order, we're looking for groups. Then we'll look for exponents, multiply, divides, adds, and subtracts. And we see, oh, there's a group right here. And that group has a lot of junk in it. And in fact, inside the group is another group. So this one's got groups in groups. Now, if you have a group inside your group, the innermost group is where you begin. So I can't do this one yet. This outside big group, can't do, because it has a group inside of it. So we got to do the group inside first. Okay, so here we go. 20 divided by 5, weight, plus 4 squared, weight, times the group. Now inside the group is some math we have to do. And it has its group. Inside of its group, we're going to do 13 plus 4, which is 17. Now, have we finished that group? Nope. So we're not done yet. We're still working on that group. So let's finish off that group. 20, the division has to wait. The add has to wait. The second power on the 4 has to wait till we're done with the group. So 17 minus 8 is 9. There we go. the group is done. Now, you could drop the parentheses. It is going to be a multiply when I get to that 9, or you can put a times dot if you prefer. Whichever, well, since the group work is all done, it is a multiply problem, you can do it either way. But I think I'm just going to stick with the bracket group, and now I'm going to move on. The group is done. Check. Next, we're looking for exponents. Okay, this has a couple of exponents. So I'm going to go left to right, like a typewriter, and do exponents. 20 divided by 5. The division is waiting, plus is waiting, but there is a 4 to the second power. That can no longer wait. It's time to do exponents. 4 times 4 is 16. Times the 9. Now I have to wait on that. Minus has to wait, because I haven't done all the exponents yet. Now I have to do the 2 to the third power. 2 times 2 times 2 is 8. Okay, went left to right. All the exponents are done. Now we're going to go left to right and look for all the multiplies and divides. And it does. It has some multiplies and divides. 20 divided by 5, there's my first divide. I get 4. Adding is going to have to wait. And next, I've got 16 times 9. Now, I do want to see all the steps in your math. Notice I'm doing all these steps. There's a lot of reasons for you to get to take your time and do your steps, because when we get into algebra with the x's, there's going to be a lot of steps, and it's easy to make mistakes if you skip steps. And if you make mistakes, you get frustrated. And if you get frustrated, you start thinking, oh, I can't do algebra. But if you show steps, you're going to make less mistakes, and you're going to get more confidence, and you're going to start thinking, oh, I can do this algebra. And if you do happen to make a mistake, it's easy to go back and find the mistake and learn from it. And that also builds your confidence. So, moral of the story there, show steps. 4 divided by 5 was 20 divided by 5 was 4. Plus has to wait. But the 16 times 9 can't wait. It's time to do multiply. And you can use your calculator for that step if you need it. It turns out to be 144 minus 8. Okay. Multiplies and divides are all done. Now we're going to go left to right and do adds and subtracts. Now which one goes first? Well, this time we do get to do add first because add is on the left. And so we'll get 4 plus 144 is 148, minus 8 is 140. All done. Okay. Let's go on and keep practicing here. I'm kind of going fast, I know, but I want to keep the video as short as possible. So, oh my goodness, we have groups all over the place. This has got something new in it. But first thing first is groups. How many groups do you see? Well, you should see at least 3 groups, but that's not the correct answer. This problem has 5 groups because there's a fraction bar. So 1 group, 2 groups, 3 groups, but with the fraction bar, the top is also understood as a group, and the bottom is understood as a group. Now, when we have a fraction, we do not put the red parentheses around it when we write it. We just understand or imply the top is a group, and we understand or imply the bottom is a group. But you have to know that we've got to get the top group done. We have to get the bottom group done before we can do anything. Now, in the top group are 2 groups. So we got to do those 2 groups in the top group. So I'm going to take these off and continue to work with that understanding or assumption that the top is a group. And so we'll do the first group. 4 has to wait. And then we add the group. 6 plus 2 is 8. Plus 8 has to wait. 8 times the group has to wait. But in the group, we have to subtract. 8 minus 3 is 5. On the bottom. 6 times the group has to wait. And we have to do this third group. 4 minus 2 is 2 minus 2 squared. Okay, now, don't get confused about this. This is not a group anymore. Because there's no math. Yes, I have parentheses, but parentheses doesn't mean a group. When you have a group and parentheses, it says that because you have work to do. These were groups because they had work to do. But once I've finished the answer, I don't have any more work. So don't think of parentheses as a group if there's just a number in there. Okay, just a little tidbit pointer that might help you. Okay, next. Are we done with all our groups? The answer is no. We haven't finished the groups yet because remember, the top is a group. We got to finish that. So let's do that. In the top, it's 4 times 8. It's 32. In the top, there's an add, and I have to wait on the add because I have this multiply to do. 8 times 5 is 40. Now, let's continue to work on the bottom group. Now, the bottom group also is another group that we haven't finished. And inside that bottom group is an exponent. Exponents come before the multiply. So, we still haven't finished all the groups yet, but I am kind of shortcutting it here and knocking off that one exponent. So we'd have 6 times 2 minus 4. The exponent's done. But I really haven't finished the groups yet because the top is a group. And once you get good at this, you'll see a couple of short cuts we can make where you can skip steps. But let's see, we got 72. Now we're going to go 6 times 12. 6 times 2 is 12. 12 minus 4 is 8. Now you just saw me skip a step. I did the multiplication. On the bottom there's a multiply in that group. And I did the add and subtract. So I kind of skipped a step there to get the 8. And as long as I'm seeing the big steps there, I'm happy. And if I'll just leave it at that. And lastly, we can simplify that fraction, right? That's easy. Divided by 8, we're going to say, oh, that equals 9. We simplified that expression down to its smallest value. Okay, before we go on to a couple of the harder ones, I want to introduce you to a couple of algebra principles. Now, in a previous class, we have talked about opposites, but now I want to use opposites of a group. So technically what we're looking at here is a negative of the group A plus B, and you can kind of think of it as multiplying a negative 1 times the group A plus B. And we have this distributive law that says multiply negative 1 times the first one, negative 1 times the second one. Now what I'm doing is I'm writing it out, all the steps, so you see the logic, but I definitely don't want you to do this many steps on paper. Once you see the logic, I'm hoping you're going to see the shortcut. So this is negative 1 times A plus negative 1 times B. And so that's going to equal negative A plus negative B. And the whole thing to get here is, notice we started out with A and it switched to negative A. We started out with B and it switched to negative B. So the whole group went to its opposites. The opposite of a sum is the sum of the opposites. And that's what we have here. It was A, now it's negative A. It was B, now it's the opposite of B. Okay, so that is just the distributive law at work. Now, we have a shorter way of writing negative A plus negative B. There's too many signs with the parentheses, the plus, and the negative. So you need to fill this blank in your notes, but it's a lot easier to write this as negative A minus B. And it's still the same, it's equivalent. Notice going back here, we started out with A, and now we have the opposite of A. We started out with a plus B, and now we have a minus B. That's the same thing as the opposite. It's just that this one is easier to write. So the middle one's okay if you want to write all that extra stuff, but you don't have to if you can understand the shortcut I just gave you. Okay, so let's practice. Here we have an algebraic expression at the bottom. Negative of the group 7x plus 9y minus 5. Now, we're going to skip all of this here at the top like I did. If you really have to use the distributive law, multiply by -1 to make sure you're getting the right answer, go ahead. But I'd prefer that you just understood, oh, it's the opposite. Make the opposite of 7x. Okay, that's -7x. Make the opposite of plus 9. Oh, that's minus 9y. Make the opposite of -5. Oh, that's easy. That's plus 5. So notice in the group, the 7 went to -7, the 9 went to -9, and the -5 went to +5. That's it. That's how you can take an opposite of a group. It's pretty straightforward. I hope that kind of clicks for you. Now, I got another principle. Another algebra principle. You have to fill this in. Make sure you write down like terms there. That's a word I want you to understand. A like term is a part of an expression that like terms are part. Oh, I wrote the grammar bad. Like terms are parts of an expression that have the exact same variables. Put a little S there, fixes the grammar, I think. Like terms are parts of an expression that have the exact same variables. The coefficient is a number. The coefficient is a number multiplying the term. You can simplify by adding and subtracting like terms. Now, there's a lot of vocabulary here. But first of all, like terms. Let's say we have 7x plus 11x. This is an algebra expression. It has two like terms in it, the 7x and the 11x. Now, notice they both have one x. They have the exact same variables, which means these are like terms. Now, in algebra, whenever you run into like terms, we can't get the answer because we don't know what x is, but we can simplify. We can combine two terms in together. Think of it as like 7 apples plus 11 apples. And what we get when we combine them is we add the coefficients. We add the coefficient 7 and the coefficient 11, and we get 18 apples. Or in this case, 7x plus 11x is 18x. Here's another example. 2a squared minus 7a minus 9a squared. Okay, this is an expression with different terms in it. It has 3 terms, but 2 of them are like terms. Remember, they have to have the exact same variables. So a squared, that term has 2 factors of a, and negative 9a squared has 2 factors of a. Those are like terms because they both have 2 a's. The one in the middle is not like. It is not a like term. So the ones in boxes are like apples and apples, and the one in the middle, 7a, is like an orange. It's not like the other 2, so we cannot combine that one. But the 2 in the boxes we can simplify. So we get 2a squared minus 9a squared equals negative 7a squared. Now we're still left with this other one, minus 7a. Now, does that equal negative 14a? It does not, because a squared and a are not like. So I cannot simplify anymore. This is done. It is as simple as we're going to get it. This is the idea of simplifying with like terms. Now here's one last tricky one. 6x squared y minus 5x squared y. Oops, no, that's not what I wanted to write. xy squared. This is stuck. We cannot simplify. They are not like. They have to have exactly the same variables. The first one has 2 x's and 1 y. The second one has 1 x, 2 y's. So the one on the bottom, we cannot simplify. That's the idea of like terms. Now we're going to look at a couple more algebra expressions, and we're going to use all the things we have to simplify them and make them as simple as possible. Here we go. 7x minus 3 plus 4 times the group 2x minus 5. Now we don't know what x is. We cannot evaluate this, but we can simplify it. Now, when we're simplifying it, the basic plan is get rid of parentheses. That would be the first thing you do. There's one more thing you can do. Combine like terms. When you run into hard algebra expressions, this is what you want to do first. Make it as simple as possible. Later, we're going to turn these into equations and we're going to solve them. But this one we have in front of us is way too hard to solve because it's too complex. We want to make it simple first. So this is important to practice. How do you simplify? And I see parentheses there. So we can use the distributive law, get rid of those parentheses. So this will equal 7x minus 3. Notice I'm not doing anything there. Plus, that's got a weight, but the multiply times 4 I can do on the group. 4 times 2x is 8x. 4 times negative 5 is minus 20. So we've done something pretty important as far as simplifying. Getting rid of the parentheses made this a lot better. Next, are there any like terms? This expression has 4 terms, the 7x, the minus 3, the 8x, and the negative 20. And some of them are like 7x, the 8x. So we can combine those. 7x and 8x, just add the coefficient numbers, add the 7 and the 8. And that gives us 15x. But wait a minute. Look at the negative 3. That's just a constant number. Just a number. And the negative 20. That also is a negative 20. It's just a number. Now, like terms have to have the exact same variable parts. Well, both of the green boxes have no variables. That's exactly the same. They're both like terms. So the numbers, we can treat them like terms and combine them as well. A negative 3 combined with a negative 20 makes a negative 23. And that's it. We're done. This is simplified. The 15x has x's and the 23 doesn't, so we're stuck. We can't do any more than this. But we did take that complicated expression and made it way simpler. Here's one more that I'm going to do. I have one more that you're going to do after that. Okay, now I see lots of y's all over the place, but there's a group. Remember, simplify groups first. We want to get rid of parentheses. And the parentheses are kind of blocking us up. But wait a minute, we know how to do this. We can treat this as an opposite. Okay, so I'm going to keep the 8y squared minus 3y. Now I'm going to use that opposite law and say, okay, subtraction. I'm going to treat it like an opposite, the opposite of 2. is negative 2. I'm going to put the negative there to emphasize that the sign changed. The 2 became a negative. Now I'm going to do another opposite. The opposite of negative 6. What's the opposite of negative 6? It is a plus 6y. All right, so when there's only a negative on a group, I can use the law of opposites to change the signs of the group. And that takes the parentheses off. And now I'm much simpler. But I can make it even more simple. If you notice here, I have a second power of 8 and a second power, I said that wrong. We have a second power of y and another second power of y. Those are like terms. We can combine the 8y squared and then minus 2y squared equals 6y squared. But we also have a 3y, negative 3y, and a plus 6y. So a negative 3y and a plus 6y, they are like terms. They both have only a single y factor. So we can combine these, and we get plus 3y. Now, let me pause for a second, let you digest that and write that. Okay, wait. Does this equal 9y squared? Oh, 9y cubed. No, it does not. I cannot add this. It's stuck. It's done. It doesn't go any further. It is as simple as it gets because this one is a y squared and that one's a y. They are not like. So it took us 2 steps and we got it to be as simple as possible. Okay, last one. This is the more complex one, the most complex one we've got. And I'm seeing, I can use the opposites there. But I'm also seeing a group. And inside that group is another group. So I have a group inside a group. So we have to use the order of operations to do the inside group first. After we get that done, get rid of those parentheses. Then we can do the outside group and see if we can simplify that. And then we can do the opposite. Now, I want you to do this problem. So I'm going to ask you to pause the video and work it out. Okay, I'm still waiting for you to do it. Okay, go ahead, you do it. A person who makes a mistake grows their brain more than the person who gets it right on the first try. So you can do it. Give it a try. Okay, I hope you did it. Now, I'm going to do it. And I want you to grade yourself and go back and check it. I'm going to go pretty fast, so you can pause or you can just look at my steps. But here we go. Inside group first. Okay, so I couldn't really do the group because I didn't know what W was. But I could do the distributive law, and that's what I wrote down. Multiply, I want the red to come up here, and it's not. So I did 3 times the W cubed, and I did 3 times the 2 and got negative 6. And I see I made a typo there. I should have W cubed here. Okay, now I did the innermost group. I still have the group to do. I don't know what W is, but I can at least simplify inside the group, and I have 2 like terms here. Okay, there you can see I put negative 6 plus 5. Those like terms went together. Now I have a group still, but I cannot do any more work in the group. But outside the group happens to be a subtraction. I'm going to treat that like an opposite and do the opposites here. So the 3w cubed became negative 3w cubed, and the negative 5 became plus 5. Wow, I am almost done here. I see some like terms, so I'm going to combine the like terms. There are w cubes, so those are like 2 apples and apples, and there are the, I better use a different shape, 5s, the 2 5s, and they both happen to be positive. So that would be my final answer. 7w cubed minus 3 is 4w cubed. 5 plus 5 is 10, and that's it. That is the simplified expression. Okay, study hard on this, really practice a lot. Mom has some more practice on this. I hope this was helpful, and I'll see you in class. Bye-bye, everybody.